Okay, so today we're going to talk about how we're going to solve an equation like this. I mean, a differential equation, and we're going to be, we're going to be using the Legendre polynomials method. All right, so how are we going to do this? Now, first of all, I want to test something. Now, I've got 1 minus x squared here, that y double prime minus 2xy prime plus n into n plus 1y. So, firstly, if x is equal to 0, then px is not going to be equal to 0, meaning that x is equal to 0 is an ordinary point. Therefore, if it is an ordinary point, I'm going to be using the series y is equal to the summation with ar x power r going from 0 to infinity. Immediately if I open this up, I'm going to get y is equal to, if I put 0 here, 0 here, so when r is equal to 0, okay, I'm going to get a0. When r is equal to 1, it's going to be a1x, then we're going to have a2x squared plus a3x power 4 plus, a3x power 3 plus a4x power 4 and so on. I can also differentiate the series y is equal to all of that here. So if I do that, I'm going to get y prime is equal to the summation going from r is equal to 0 to infinity and ar times r x power r minus 1. The second derivative of this is going to be equal to y double prime is equal to all the series here from 0 to infinity ar r into r minus 1 times x to the power of r minus 2. Having differentiated the series twice, so what we're going to do now, we're going to take y prime, y double prime, and then substitute all of that into the original differential equation. So if we do that, let us see, 1 minus x squared, so 1 minus x squared times y double prime is all of that there, so summation from 0 to infinity, and I've got arr into r minus 1 x power r minus 2 minus 2x times y prime, and y prime is all of this, so summation again from 0 to infinity, and over here I've got arr x power r minus 1. Next is plus n into n minus 1, so n into n plus 1, and of course if we do this, we put y here, and y is the series from 0 to infinity ar x power r. Alright, and all of that should be equal to 0. Now where do we go from here? Very easy. Okay, so first of all what I'm going to do, I'm going to distribute x squared and also x into the series. If we distribute this, alright, so we're going to get 1 times this whole lot here. So that's going to be summation going from 0 to infinity ar r into r minus 1 x power r minus 2. Then minus the x squared goes in the series, and this is going from again r is equal to 0 to infinity, and then I've got arr into r minus 1 x power r, because the minus 2 cancels out as 2. Right, so now minus 2x, so that's minus 2. I'm going to distribute x into the series. So here we're going to get the summation again now going from r is equal to 0 to infinity, and over here arr, right, x power r, because the minus 1, okay, cancels out with x to the power 1 here. There's n into n minus 1, n to n plus 1, and then the summation again from r is equal to 0 to infinity, and all of that, times ar x r is equal to 0. Okay, this is getting very interesting now. So what I'm going to do is we'll take the series again from its beginning here. Alright, and this is ar, there's much change here, r minus 1 into x r minus 2. Right, so the next stage, I'm going to take all of this expression here, send it to the right hand side. So if I do that, summation going from r is equal to 0 to infinity. At the same time, I can also factorize the summation. Summation AR, summation AR, summation AR, XR, XR, XR. Very good. So summation AR can be outside, and then inside the expression I'm going to get, right, so R into R minus 1, okay, right, minus 2 times R plus n into n plus 1, okay, times, okay, so that's it, and then all of that x to the power of r. Right, interestingly speaking, this was minus, comes here, becomes plus. The minus becomes plus because remember we set this on the right hand side, and so here the plus becomes the minus. Alright, and the only problem with this is that I have x power r over here, and I got x power r minus 2. So how am I going to deal with this? I'm just going to put r is equal to r plus 2. If we put r plus 2 into this, because of space here, I'm just going to wipe the screen a little bit. So this r becomes r plus 2, and so we have a r plus 2 now, and all of that here becomes r plus 2, because our r becomes r plus 2. So r minus 1 becomes r plus 2. So r minus 1 plus 2 is r plus 1. Right, and therefore this goes away because r plus 2 comes here, becomes r. So all of that is equal to this. Now, interestingly speaking, so we can cross out and cancel out the like terms on the left hand side and right hand side as well. So I'm going to cross this out, I'm going to cross this out, okay, and I can cross all of this out, cross all of that out. So what I'm left with is AR, so I mean AR plus 2, and then is equal to, I mean this R plus 2, R plus 1, all of that can be divided on the other side. So is equal to, on the other side I've got R times R, which is R square. So R square here, then minus R plus the 2R, minus R plus 2R is going to be equal to plus R. So plus R minus n into n plus 1, and all of that being divided by R plus 2, R plus 1. And then of course I've got the AR. Now we are almost there. So what we're going to do now, let's take a look here. We have R, so we can just say when R is equal to 0. What's going to happen if R is equal to 0? I'm going to get A2. So this is going to be A2 is equal to, so 0 squared plus 0 minus n, so minus n into n plus 1 times, divided by, if I put 0 here, 0 plus 2 is 2, 0 plus 1 is 1, so 2 times 1 is 2, and I got A 0, because R is equal to 0, so AR is 0, right. So when R is equal to 1, so I'm going to get 1 plus 2 is 3, so I'm going to get A3 is equal to, so 1 squared plus 1 is 2, 2 minus n into n plus 1, okay, all of that divided by 1 plus 2 is 3, 1 plus 1 is 1, 1 plus 1 is 2, 2 times 3 is 6, so I got 6, and then this is A1. So when R is equal to 2, I'm going to get A, 2 plus 2 is 4, is equal to, so 2 to the square is 4, 4 plus 2 is 6, so I get 6, minus n into n plus 1, okay, and all of that divided by, because this is 2 now, 2 plus 2 is 4, 2 plus 1 is 3, 3 times 4 is 12, so I got 12, A2. In a similar way, when R is equal to 3, I got A5 is equal to, so let's get some space here, so A5, alright, is going to be equal to, R is equal to 3, so I got 3 to the square, which is 9, 9 plus 3 is 12, so 12 minus n into n plus 1, and I've got all of that divided by, here I've got 5, because 3 plus 2 is 5, 3 plus 1 is 4, 4 times 5 is 20, and I've got A3. Now these are some of the values that we're going to be needing to put into the equations. And so our equation was, what was it? It was over here. So when we open up, so this is what we had, the solution of the equation. So all of that's going to be equal to now y is equal to a0, okay, plus a1x plus a2x squared plus a3x cubed, a4x power 4 plus and so on. So basically now I can factorize a0. If I put a0 outside, I'm going to be left with, if I deal with this, okay, so that's going to be then into 1 over here, a2, so a2 is, okay, so plus a2 over a0 times x to the square plus and so on. Now, if you look at this carefully, the 0 cancels out, and x squared is left with a2. And ax1 is over here. So this is 1, a times 1, a0 is, what is a1? Now having dealt with a0, I'm going to deal now with a1, so I'm going to factorize a1 with a3. So I'm going to say plus a1 factor out, inside I'm going to be left with x, because x times a1 is back to a1, and because I'm dealing with a3, so to get a3 back, I'm going to put a3 over a1, because a1 is going to cancel, this gives you back a3, x to the cube, plus and so on. So we can go on forever like this. Right, so what we're going to do now is going to try and find some values. So now y is equal to that. Again, basically this is our solution now. Alright, so I've got a0 into 1 plus. What about a2 over a0? So over here, if I put a2 here, and then I've got a0 here, the a0 can come down here. So if I just wipe this clean, and I put this a2 over a0, that's going to be minus n into n plus 1 over 2. So plus becomes minus here. So minus n into n plus 1 over 2, and then you got your x squared plus a, now a1 into, okay, I've got x, alright, plus, now a3 over a1, we're going to do exactly the same thing that we just did now with the a1 and a0. So this is now a3 over a1. Here's a1. So what I'm going to do, I'm just going to cancel this here, put my a1 underneath here. So a3 over a1 is 2 minus n into n plus 1 over 6. So there's a minus, there's a plus here. So I can put plus, then in brackets, I've got all of that. But can we simplify this? Because I see this, there's a 2 here, there's a 1 here. Maybe I can simplify this. So if I do this, probably I'm going to get, let me see. All right. So 2, okay, minus n squared minus n over 6. Can we actually factorize this? Yes, because if I put the minus outside, I'm going to be left with n squared plus n minus 2, right, isn't it? So, and that is going to be over 6. So n squared plus n minus 2 is basically n minus 1, n plus 2, right? Because 2 minus 1 is 1, and so this divided by 6. So basically what we're looking at is this. This is very important. That is the equivalent of this. So I'm going to say, I'm going to wipe this clean now, and I'm going to put n minus 1 into n plus 2 over 6. So basically now this plus is going to become minus n plus, is that plus 1? So now n minus 1, alright, and then into n plus 1, and all of that being divided by 6. So over 6, and I've got my x cubed plus. Now basically you could have factored x outside if you wanted, but I want to put the constant outside. So basically that's my general solution to this differential equation. And over here I've clearly shown to you how we're going to be using Legendre polynomials. As a French guy, Legendre, a French mathematician, I pronounce it quite well because I speak French as well, Legendre. I hear some people from India
Even the English people, they say legendary, but not legendary. It's Legendre. Alright, take care. I hope that video helps. If you're doing your BSc Maths or Maths for Engineering, that could be of some help over there. Take care.